Hello viewers. In this chapter we shall discuss the fundamental concepts and the physical quantities associated with rest and motion. The branch of physics which deals with the study of forces and motion and their relationship is called mechanics. The study of mechanics is divided into three parts: statics, kinematics, and dynamics. Statics deals with the objects at rest. Statics plays an important role when we design stationary objects like bridges, buildings, and other structures. In kinematics, only the motion of an object is discussed, without considering the cause behind it. In dynamics, the cause of motion is studied in detail. Now let us define rest and motion. An object is said to be in rest if it does not change its position with respect to its surrounding with the passage of time. On the other hand, when the position of an object changes with respect to its surrounding with the passage of time, then the object is said to be in motion. Now, we often say rest and motion are relative. Why is it so? To elaborate, we need to know about frame of reference. Let us consider a situation where three persons are taking some measurements from three different places simultaneously. The first person standing beside a tree, the second person took observation from a car, and the third person from a flying plane. The first person standing beside the tree estimated the velocity of the car around 20 meter per second and of the plane around 150 meter per second. Obviously, for him, the tree remains stationary, hence the tree is having zero velocity. Now let us consider the observer who is traveling by car. From inside the car, the observer finds the car is stationary, however, the tree is moving backwards and the plane is coming towards him much faster. He estimated that the tree is moving behind with the velocity 20 meter per second and the plane is coming towards him with velocity 170 meter per second. As the car is stationary, it is having zero velocity. Finally, let us consider the observation of the observer sitting in the plane. To him, the car is moving with a velocity of 170 meter per second and the tree is moving with a velocity 150 meter per second. Obviously, he finds himself stationary inside the plane. We find here three observations of the same incident with completely different outcomes. It may be difficult to believe, but observation is correct based on the frame of references associated with the observers. Hence, the frame of reference can be defined as an abstract coordinate system and the set of physical reference points that uniquely fix the coordinate system and standardize measurements within that frame. Now let us discuss two physical quantities which are very much associated with rest and motion. These two quantities are distance and displacement. In the picture, objects can move from point A to point B in various ways in some time interval. The particles can take path 1, 2, 3 or any other path. By doing so, it will travel some distance. However, among these various paths, the path having the smallest distance between these 2 points is a unique one. In the present illustration, it is path number 2. As for definition, we can say the total length of the path traveled by an object during a given time is called the distance traveled by the object in that time, and the shortest possible distance from the initial to the final position of an object is called displacement of the object. Distance covered do not have any direction. However, displacement between point A and point B will always be uniquely directed. Therefore, distance covered can be represented only with the magnitude. However, in case of displacement, directions also get involved. Physical quantities which can be expressed using only magnitude are termed scalar, whereas if both magnitude and direction are required, then they are called vector. Hence, distance traveled is a scalar quantity and displacement is a vector quantity. Few other related physical quantities are speed, velocity, and acceleration, which are defined as follows. Rate of change of distance covered with respect to time is defined as speed. Rate of change of displacement with respect to time is defined as velocity. Rate of change of velocity with respect to time is called acceleration. In nature, various kinds of motions can be observed. In general, they are classified into three main categories. These are translational motion, rotational motion, and oscillatory motion. A body is said to have translational motion if each particle of the body has the same displacement in the same time interval. In other words, in this type of motion, every particle of the body covers a definite distance in a definite time in a linear path. If a single particle or a point mass moves in a straight line, then it is called rectilinear motion. More on particles or point mass shall be discussed in a moment. In case of rotational motion, each and every particle of the body travels in a circle, except those which reside or stays on the axis of rotation. The axis of rotation is a straight line that consists of the centers of the circular motion of the particles. If a single point mass moves in a circle, then it is called circular motion. A body said to have an oscillatory motion if it moves to and fro repeatedly about a fixed point called mean position. To avoid the complexity in describing the rest and motion, we often use the term particle or point object. A particle is defined as an isolated point mass having no size and incapable of rotation. By no size, we wanted to make sure a point object remains dimensionless. However, everyday objects are not particles. They take up space and certainly not dimensionless. Depending on the circumstances, we can say whether an object can be treated as particle or not. In describing the motion of a car, which is bound to travel hundreds of kilometers, we can consider it as a particle for all practical purposes. Similarly, a spaceship traveling towards the moon can also be considered as a point object. So, in general, point objects should be small enough in size when compared to the whole scale of observation. The space we live in is three-dimensional. That is, we can specify the position of any point in space with the help of three numbers. A convenient point can be chosen as the origin and the three mutually perpendicular axes as shown in figure from the simplest coordinate system named Cartesian coordinate system. We need three numbers along the three axes to locate any point in space. In case of three-dimensional motion or motion in space, we need the information of all the three coordinates for the initial as well as the final point. If the motion is restricted to a plane, in that case, we only need the information on only two coordinates. In case of one-dimensional motion, we only need information of one coordinate to specify the location of a point at any instant. For the measurement of time, t equal to 0 is considered the instant at which we generally start the measurement or the study of motion of the object begins. Using one dimension, we can describe particle motion in any particular direction. The convention of taking the positive and negative values of displacement on a plane are shown in the figure. Now let us discuss the time displacement curve. When an object changes its position towards a particular direction with respect to time and the phenomena needs representation in the graphical form, it can be expressed in this manner. Another interesting plot is the time velocity plot. Suppose an object is moving with velocity v over a time interval t1 to t2. This kind of situation can be expressed using the following curve. Considering the particle is moving with a uniform velocity over a time interval, then the area of the shaded region is nothing but the distance covered by the particle within the time interval. Using this concept, we can also find out the distance traveled by a particle having non-uniform velocity. It will be nothing but the area under the curve of Vt plot in some particular time interval. To sum up, in this session, we have discussed the branch of physics which deals with the study of forces and particle motion and their relationship known as mechanics. We have understood the concept of frame of reference, understood various terms like distance traveled, displacement, speed, velocity, acceleration, etc. Various kinds of motion and their representation in 3D, 2D and 1D with the conventions of measurement using the Cartesian coordinate systems are also discussed.